topic is Rust and the point of Rust. Rust is a new language from Firefox. It's extremely popular among developers. Something like 90% of developers say they would rather be using Rust, but very few people will let them use Rust because Rust is new and people aren't sure whether they like it. But the point of Rust is it is much more secure than C and C# and C++ and all the derivatives. C is very close to assembly code, and all the major security problems that we see in code come from C being misunderstood by developers, so they make errors. There are a series of common errors that people make in C code that lead to disastrous consequences, and Rust is carefully designed to prevent those errors. So this, we'll put it in on a Linux machine, and I've got my Linux machine here. All right. Well, I thought I did. Maybe I got to refresh it. Okay. .17? Maybe just 17. See if I get it right. Yeah, I think I got it right. Okay, good. Yeah, here's my Linux machine running Velociraptor, and I don't need that, but I do want the instructions so I can copy and paste code. So let's, there we go. And it looks to me like it's a little bit off the visible screen for the, there, that's pretty good. All right. So, Rust is down here someplace. There's Rust. All right. And so I want a terminal, which I guess I've got one right there. That'll be fine. Okay, let's go home. And, all right. So sudo apt update. All right. And then install these things. Copy and make this use less than the whole screen. Gonna let me grab that corner or what? Maybe you're not. Okay, I can do that. That's a start. How about letting me do it the other way? All right. How about letting me grab this side? Okay, that'll do. All right. These, that's not bad. Okay. So now I should paste in this stuff. There we go. So I'm installing Rust. First, curl and build essential in GDB. Oh, somebody's in the waiting room. All right. All right. And then Rust, which I think I didn't, let's see. Nope, okay, didn't put in Rust yet, so let's do that. Rust C is the Rust compiler. All right, so we have to do this. I'm not sure if you really have to do this with this installer, but it wouldn't hurt, I guess. All right, I guess it doesn't matter. We're going to find out pretty soon. So I make a directory for the Hello World app. You put each Rust program in its own folder, which is the way most modern programming languages work because they think you're going to have multiple components, not just put everything in one file. So here goes hello.rs, and here's the code to say hello world. You make a function main that prints a line that says hello. Looking a lot like most other languages. Escape Y will make it easier to see. Control X, Y, enter. We'll save it, and now you Rust C that file. And it worked. All right, good. All right, so there's hello saying hello. So that just proves that Rust is in fact compiled. All right, and now we can make a program that manipulates integers. All right, and here's some code. And we're going to begin to see why Rust is more secure. When you define a Rust variable, you can do this, let I equal 1, and it will just guess what type to make it, but you can also explicitly specify what type. And so J is an unsigned 32-bit variable. It's specifically defined there, and that is the way to make it safe, is to specifically tell it what kind of variables things should be. And if you run Rust C on that, it will tell you you can't do that, which makes sense. You cannot take an unsigned variable and put a negative number in it. It won't let you do it, which is good. And so there's a very wonderful tutorial here, which you can check out if you want to actually learn more about the Rust data types and how to build Rust. This covers a lot of languages. These tutorials point. These things are great. And so I got a link there. You can read up on data types and figure out how to get the next flag. But let's get to adding numbers. And I'm not very interested. We're going to skip past that one. Let's get to comparing it to C. Here's what I wanted to do. Okay, so let me show you why Rust exists. Nano ovc.c. This is an integer overflow in C. So here's the code. All right. So what's going on here is it has an unsigned character, x equal 230. And right now, this is madness. But this is how C works. A character variable is named because it's enough room to put in one letter, like A or B, but it's stored as just an 8-bit value, which can also be interpreted as an unsigned integer that goes from 0 to 255, and C encourages you to think of them as the same thing. So it's perfectly happy for you to define it as a character and set it equal to a number. And you're just supposed to understand that it's only 8 bits in size. So if you start adding to it, if I just add more numbers to it, weird things happen. If I hit Control X, Y, enter, and I compile this with the C compiler and run it, I probably can't use key presses. I better use the mouse. All right, the mouse is not working now. What's the deal here? Nope, it's really not. I must probably because I tried to hit buttons down here. Okay, copy, paste. All right, so I compile it and I run it. So you start with 231 and you add numbers, and when it gets too big, it rolls over like an odometer and gets small again. And you're just supposed to know that if you program C. You're supposed to know that since you defined it as a character, that means it's only 8 bits in size, and when it goes over 255, it'll roll over and be a small number. And as you might imagine, a lot of developers do not remember that. And so you get weird integer overflow problems where you want to make sure something is not bigger than a certain size, and all you have to do is make it a whole lot bigger so the size rolls over and turns negative, and now it will pass that test when it shouldn't have passed that test. So this is the integer overflow, which causes a whole class of vulnerabilities in C, and that would not happen in Rust. So let's make the same program in Rust. So here is the usual preamble to prepare a directory and put in some Rust source code. And here's the Rust source code that does the same thing as that C code. It defines a mutable variable, otherwise they're immutable and can't change, as an unsigned 8-bit character, which is what C calls a char. So now I put 230 in there, and then I keep adding numbers to it more and more, and let's see what happens. So we compile it with the Rust compiler and then run it. All right. And so it gets bigger and bigger, and when it was going to roll over, it gives me an error message. Attempt to add with overflow. Now this, I think, is much more sane to developers. If I had a number that was 250 and I add something to it, it should get bigger. Don't turn it into 2 and expect me to understand or remember why that happened. If you have an unsigned integer that's only 8 bits long and you try to put in a number that is too big, Rust will just stop and tell you. Something's wrong here. You can't do that. So that's why it's safer. The number is more intuitive. It meets more what a normal person would think that number would do. All right. And a string overflow, the classic buffer overflow that causes tons and tons of vulnerabilities in C. Let's do that. This is probably the biggest vulnerability in the last 20 years. Classic buffer overflow, straight from the article by Aleph Null in Frac. So here we go. This is the simplest version of it, where you overflow from one variable into another. So here's my code. I make a string that's 5 characters long that has AAAA, and then there's a null byte at the end to terminate it, and then I would do the same thing with string 2 is BBBB. So I just print them out. Then I read a new value for string 2, and then I print them out again. That's all. So I compile that thing and run it. All right, and so if I put in a short string like CCC, then it works. String A1 contained AA, and after this it still contains AA. String 2 was BBB, but now it contains CC. So that's fine, nothing went wrong. But if I put in a long string like this one, then weird things happened. I put in a new value for string 2, but string 1 changed. String 2 cheerfully contains 20 characters, even though I only had room for 5, and string 1 now contains the second 2/3 of string 2 because of the addresses. It stored string 1 at 70B and string 2 at 706. So when you put more than 6 characters into string 2, it just leaks into string 1. And again, I say this should drive your developer insane. I mean, I added a value for string 2. How was I supposed to understand that that was going to change string 1? Why would anybody use a language like this? How are you supposed to keep control? And the answer is, it's really hard to keep control. And there's a whole class of buffer overflow vulnerabilities where the data leaks out of the bounds of the reserved memory and tramples on top of other memory and creates tons of vulnerabilities. And again, this will never happen if you use Rust. So here's the same program in Rust. By the way, it won't happen if you use Visual Basic or Java either, but the point of Rust is it's supposed to be as fast and efficient as C without all the vulnerabilities. And so here's the same thing in Rust. Again, I define a mutable string, AAA, BBBB, then I just print it out, do IO standard in read to read from the user, new data to go into there, and put that in string 2, and then print it out again. Or anyway, that's what I do. So a new value for string 1 in this case, but it doesn't matter. All right, so now Rust C. I compile it with the Rust compiler and run it. It gives me a warning, but it doesn't complain. All right, so now I got AAAA, BB, BB. So if I give it CCCC, it adds that to the existing contents of string 1, which is a little screwy, but it does not leak into string 2. And string 1 is at C70 and string 2 is at C88. So it seems like a long enough string would in fact leak out of string 1 into string 2, but it won't. So even if I put in this stuff, really long stuff, it just cheerfully adds all of that to the end of string 1, and it doesn't change string 2 at all. This is just what it should do, right? I change string 1, it changed string 1. Does not change string 2, doesn't matter how long I make it, because it will just move the pointer and allocate more room. Now the pointer still points to the same address, but that's because this location doesn't directly contain the data. It contains another pointer to where it's stored, and that pointer was changed to another location that made enough room. So there is no longer any buffer overflow. If you put too much data in a buffer, it will automatically just make the buffer bigger to correctly store the data, which is much more sane. And you can actually go into the debugger and see exactly how it stores it to understand how that happens. So, all right. And there's command injections where you have vulnerabilities, and those still happen. But anyway, the major vulnerabilities, also heap double free that leads to heap vulnerabilities, again, doesn't happen in it. So they're talking about rewriting part of the Microsoft operating system in Rust in order to make it more secure. And a lot of people are considering this, that they should switch to Rust. So if you're interested, try doing a few of these things. You can learn a little bit about Rust, which is the up-and-coming, more secure language to replace C for at least some purposes.